This is where we'll get into a little some sparring here. So again, I've been doing hybrid for 25 plus years. I think it can be an equal partner. I think in some cases it can be the better choice, but there's also certain cases that you absolutely don't need to do that. So the philosophy generally is do the simplest thing you can do to get your answer. And if the simplest thing is already there, or it's an LBA or something, why go use a fancy screwdriver, Dom's saying, when I can just use a plain screwdriver, right? It doesn't make sense to do that. So I would like it to get all the way to an equal partner, but at the same time, there's not enough, quite frankly, people that do this technology that would allow it really to be completely equal.
I think that's really like germane to the conversation. It's people tend to want to do the platform they're familiar with. So if you're a ligand binding assay group, you're going to be more inclined to solve the problem doing it by ligand binding assay. If you're more comfortable with mass spec, but there are situations where it's much more beneficial to fail at the LBA side, knowing that you have the hybrid. And what I mean there is, if you're looking at like oligos, really small, say modalities, small drugs, where there's, I often say, lack of real estate for an antibody to bind to it. So. And Don kind of alluded to that, meaning you could have an antibody that doesn't have it's low avidity, low affinity, it's not very specific, I kind of use the word promiscuous, it might bind to a bunch of different things. Well, in a ligand binding assay scenario, that's a disaster. But on a hybrid mass spec side, that's where the LCMS piece of it can sort that out. So, but oftentimes it may take a little bit more effort to do that, right? So if you can do it by LBA, that's an advantage. And then there's some other things that really are advantageous, like total and free.
Yeah.
Phosphorylated and total.
Yeah, bound.
What we mean, bound. So what we mean by that is the ligand binding assay approach is like, you can't multiplex that, where on the LCMS side you kind of can, and maybe you can elaborate a little bit more on what we mean by that.
Yeah, so and the other thing I'd say, even before I get to that, is there's a lot of times when, like LBA, a lot of times you have to have two good reagents, and for mass spec, really the second detector reagent is really the mass spec. So that gives you this ability to dial in selectivity to what you want. So a lot of times you have an antibody drug. Let's say one antibody binds this piece, the other antibody binds this piece. Well, that's the only thing you can tell. There's this piece and this piece. But in mass spec, you can grab this piece, and then I can look at this piece, this piece, this piece, that piece, and this piece, and I can tell you all of those are there just by picking all those different peptides. And so that allows that technology to get a little bit more multiplexed, whether it's within a molecule or between molecules. So sometimes we have examples with ADCs where you can grab the antibody and it has some things hanging off of it, like payloads, and other times it doesn't. But we can differentiate that and get both in one assay. So there's a lot of ability to leverage and multiplex very easily, and he also alluded to sometimes you have a small sequence change, or you have something that's slightly different, that it would be hard for an antibody to differentiate. Let's say you have a 10 mer or a 20 mer and you have one amino acid that's different. There are antibodies that can pick that up, but it's not as common.
Yeah, and
it's very easy for a mass spec to pick that up.
Yeah, that's a good point. Like an endogenous versus a recombinant version of a protein, a mass spec approach is what we would recommend out of the gate. We just think that's probably, unless you have, as Don alluded to, like a known entity that can bind each of them independently, then the ligand binding assay is preferred. I would say, like, we're talking a lot about the power of hybrid there. On the converse side, things like pegylated compounds, anything that's going to kind of, what do you call it, your rails or something?
Yeah, it gets messy and gets dirty.
Then the ligand binding assay approach is probably a better approach to go at it. And that's not to say you can't find good reagents that you can capture with, and then you can come back and detect with a different reagent. So there are ways to do ligand binding assays that can look at total and bound and free and bound, and the if it works, then the LBA is a good way. If you have to optimize and develop it, that's when I think the hybrid mass spec gives you more levers to pull from, because we haven't even talked about like double IPAs yet.
Yeah.
Where you have all sorts of things that you can, it's a little bit easier to maybe create some of those reagents too. Maybe you could elaborate on what I just said, because you're the expert.
There's a lot in there. So the double IP again is, you can enrich things at a protein level because you're isolating protein. So you can grab the protein and then go back and do all the stuff we said and cut it up and detect a peptide. Or you can actually, don't do this, you can make a antibody to the peptide, so you chop it all up front, and then you basically pull out the peptide on the back end, or you can do both. And so you can say, I'm gonna do a protein IP first, I'm gonna grab the protein, or most of it, right? Maybe I'm grabbing some other stuff too, and then I'm gonna also get some additional specificity by grabbing the peptide. Those, again, are unique places where every step of any kind of assay, you have to evaluate, am I getting more than I'm losing? So am I gaining more specificity? Is my signal better and my noise is less? Because every step you're going to have some loss. So let's say you had, 90% capacity here and maybe 80% in the next step. You're going to lose, you're going to lose, you're going to lose. But if you gain more signal to noise in each step, then that makes sense to then add an extra step that's going to reduce the noise more than it reduces the signal. And that's where we can get into the super low, nanogram per mil or sub-nanogram per mil. The other thing I would say on helping LBA over mass spec is, again, I hate to say sometimes, like, mass spec gets involved a lot of times when LBA can't work. And part of that is the LBA assay is a plate-based read at the whole time. You get all the samples done in one shot. Mass spec is a sequential analysis that takes X minutes for each sample. And so if you have a plate, it probably reads in, maybe it's a 2-hour, 3-hour assay, it reads in 5 minutes, right?
Less sometimes, yeah.
Like we do a day of prep, and then we have to do another 15 hours of runtime where we're doing sample by sample, and each sample is 5 minutes or 7 minutes. And so it becomes more time, and time is money. So at the end of the day, when you get into sample analysis, mass spec a lot of times will be more expensive. So when you have large studies, large clinical studies, it's going to be more cost effective if you can do it by LBA to go by LBA.
Yeah, and there's a lot what you just said there, but yeah, definitely there's some cost effects that need to be considered. We haven't even talked about like sample volumes, what matrix, all of that.
Yeah.
Like, that's part of what we do in our roles at KCAS. We help consult people on what platform might be the best one to approach, and that starts with what is the modality, what is the sample volume you get, because I think that becomes a big rate limiting factor for both platforms, independent of LBA and mass spec. But if you've only got a small amount of matrix, that really does become somewhat limiting.
And mass
I'm
spec,
going to favor LBA for that.
I know, but on the flip side, if you have more volume, mass spec can take advantage of that skill, because you can't put in 500 microliters and concentrate that and get that 10x enrichment. So there's, if you have the volume and you're in a human sample, it might be better. Mm-hmm. But if you're limited and you're in a mouse micro sample, you got 5 microliters, then we can't take advantage of that.
Yeah.
So
and independent of that, we're always working backwards. That's a big. When I say working backwards, it means if you've only got 5-10 microliters of matrix to work with, then we're going to design the method to allow for us to test in that volume. Where if it's typically a human sample of serum or plasma, you get a couple mils of that. Yeah. And as Don alluded to, in the LBA space, we have a limited quantity that we can put in that well. And even then, we have a limited amount of the minimum required dilution that we can use it at, because there's some interference within the matrix where you kind of have those flows and nanoflow and microflow that allow you to, if you can slow, right? You can put more volume on, and that allows you to detect a better sensitivity.